of yes, GATE Champion series. So guys, today's session is related to SFD, BMD and deflection of beams. Sorry for the delay guys. So we are starting the session. Kenil, good evening. Kalpesh, good evening. Yes. Amir, good evening. Thanks dear. Midun, good evening dear. So guys, do like and share the session so that other students can also join it. So as you know, because of yesterday's match, we have postponed this session today. So guys, after today's session, we will be left with only one more session for strength of material. So guys, we are starting the session without wasting the time. So as I already told you, today's topics are very, very important for both civil and mechanical engineering branch, SFD, BMD and deflection. You would be getting around 1 to 2 questions in the GATE examination from these two picks. And I am covering all the types of question in this. Yes, Irfan, good evening. Manas, good evening. Vipen, hi dear. So we are starting the session guys. Those who are watching me for the first time, this is some detail about me. I am having around 10 plus years of experience. These are my areas of expertise. And guys, I have written many research and review paper and qualified all these exams similar to GATE also. Shubham, yes, good evening. So we are starting that session guys. So as you know, this is live workbook going on, GATE Champion series. And guys, when we are talking about this GATE Champion series, we are going to cover all the subjects. And it is going to be around more than 500 questions we are going to solve for complete mechanical and civil engineering. Yes, Sunil, hi dear. Nagaraju, good evening. So here is the first question of today's session. Yes, guys. So you can see this is the cantilever beam. Okay, this is the cantilever beam. This is the fixed support. Okay, this is the fixed support. And they are saying this is the cantilever beam carries axis symmetrical load shown in the figure. Bending moment at A is MA and C is MC. What is the ratio MA and MC? So this is MA and this is C. So guys, you need to find out the ratio of bending moment at point A to the bending moment at point C. So guys, try to solve this question. I feel this type of question in the GATE examination, they have given the same figure and they asked which one of the following is the correct bending moment diagram. So I am asking you what is the ratio of MA and MC. So guys, this type of question definitely can be the part of GATE 23 examination. Yes, so solve it guys. Yes, Nagaraju, Shubham, Irfan, Manas, Vipen, Amir. Yes, solve it guys, solve it. Yes, solve it guys. I want answer from your side. Yes, guys. Yes, yes, yes. Shubhankar, hello dear. Just solve this question, guys. Okay, I will be giving you a hint also. As you know that, we are having this beam and the loading is like this. You know, whenever loading is distributed, to find out the moment, we need to consider the total area at the centroid. Okay, Shubham have given the answer to be A. Kalpesh also have given A. Nagaraju A. Okay, Vipen also have given +2 as answer. Shubhankar, very good. Yes. Kalpesh, what do you feel? Kenil, what do you feel? So guys, what we are going to do? We are going to assume that this area of the triangle will be acting on its centroid. So you know that if total length is L, the centroid will be at a distance of 2L by 3. And the area of triangle is going to be half into W into L. So my dear, if you will be finding out the bending moment at point C, if you are going to find out the bending moment at point C, you can directly write it as this area 1 by 2 into W into L, and that is going to be into 2L by 3. So guys, you will be getting, I feel 2 will get cancelled out. You will be getting WL square by 3. WL square by 3. Similarly, my dear, if you are going to find out the bending moment at point A, So this triangle area, now I am showing it with different color, my dear. This triangle area will be acting at its centroid, which is going to be at a distance of L by 3 from here. So you can see, my dear, this was creating sagging actually, because if I show you the sign convention, this is said to be sagging and this is said to be hogging, my dear. So this is creating sagging. Even if you are finding out bending moment about this A point, then it is creating sagging and it is creating hogging. So my dear, to find out bending moment at A, you will write once again the area of triangle, half into W into L. This distance is L. So it is going to be 2L by 3 plus L is 5L by 3. And you know this is sagging and second one is hogging. This is going to be area of triangle, half into W into L. And that is acting at a distance of L by 3. So you would be getting here 2WL square by 3. So if you see, this is just double than that of the previous one. So the answer is going to be plus 2, guys. A is going to be the right answer. Sachin, good evening. Bhai Sachin, आप रोज नहीं आ रहे हो, कहाँ फरार हो? Okay, question number 2, guys. Yes, Shubhankar, I have considered right hand side, because if you will take left hand side, you need to find out the support reactions. So whenever you have one end free, other end fixed, better you take right hand side. Okay. So guys, do like and share the session. Great, 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 Sachin. I was just kidding. I know you are a regular student. Yes. Sushobhan, yes, definitely you understood. It was case number 15. Very good. Great. Yes, हाँ भाई केनिल कहाँ हो आप? आज भव्या भी नहीं है शायद. Yes, what would be the answer for this one? A simply supported beam of length L is subjected to the sinusoidal loading. So my dear, this is a simply supported beam, and it is having some sinusoidal loading. But sorry, I need to make it correctly. Sinusoidal loading, it is given like this, 3 pi x by L. So this is the loading given to you. Okay, and for this loading they are asking what is the support reaction VA and VB, and they have given you WXX as sine 3 pi x by L. Yes guys, what would be the answer for this? बहुत बढ़िया. So Sushobhan have given the answer as B, Vipen B, Sachin Gautam B, Midun B, Mani B, Shubhankar, okay, Shubham B, बहुत बढ़िया, Kalpesh B, Madhuvamshi B, and yes guys, answer is B. You know that whenever we are having this WXX as W into sine N pi x by L, you know by symmetry, if N is odd, then you will be having the support reaction VA and VB as equals to W, and you need to multiply it with denominator L divided by N pi. This will be your answer. So in our case, W is 1. So you will say 1 into, this is L upon 3 pi. So the answer is going to be, my dear, B. बहुत ही बढ़िया. Very good guys. Kalpesh, wonderful. Let us see question number 3, guys, in front of you. Slowly, slowly we will increase the level, my dear. Slowly, slowly we will increase the level. Here, this question is from compound beam. My hint for this question is compound beam. Let us say how many of you give the right answer. So these are the 1 mark question of gate are going on. Then 2 mark questions will be coming. So slowly, slowly we will increase or improve the level. Yes, sir, if n is even, we go by method. Dear, if n is even, then you would be going for the, yes, method, and you would be getting VA is equals to minus VB in that case. Okay, yes. Shubham is saying A, Midun is saying A, Kalpesh is saying A. Some people would be thinking how they have solved very easily this question. Yes. Very good guys, बहुत ही बढ़िया, wonderful. Okay, I would like to say that if I would be asking you bending moment at A also, can you find it that? This is an extra question I am adding to this. Can you also give me the bending moment at A? If yes, do try this. And guys, do like and share the session. I feel today some students are not there because yesterday message I by mistaken have said that class will be from 9 p.m. So maybe that would be the confusion point. And guys, I would like to ask you, from tomorrow, can we keep the timing 9 p.m. because all other branches are running at the 9 p.m. time? Yes, if you agreed on that, from tomorrow we can keep the time 9 p.m. also. Nagaraju, Mani, Manas, Sushobhan, Sachin, Kalpesh, Midun. Answer is A, that is correct. Because my dear, this B is internal hinge. B is internal hinge. And my dear, at internal hinge, bending moment is going to be 0. But as this is a compound beam, yes, Vishweshwar, okay. Okay, fine. So 830 is fine, you want to say? Very good. Mani have given the answer as 300 for bending moment at A. बहुत बढ़िया. What about others? Very good, Abhishek, Shivam, बहुत ही बढ़िया. Very good, Shubham. So dear, you know, as it is a compound beam, we need to divide it like this. We need to divide it like this. We need to divide it like this. So if you see that, here it is 200, here it is 100. So here it is going to be 100. And if you see the previous one, here it is 200 kg. This is 200 kg. This distance is 1, 1, 1, 1. So my dear, okay, Kalpesh, don't worry, we will keep the same timing. Don't worry. Okay, fine. Naveen is saying 300. बहुत बढ़िया. Deepak have calculated RA. Dear, I am interested in MA. Bending moment at A. So if you see this, you know that by symmetry we will be calling this to be 50 kg. And this also will be 50 kg. But at this point, there was no other load. So we will be applying 50 kg downward as well. So that overall equilibrium should be maintained. So if you are finding out bending moment at this point, this 50 will be create 50 into 2, 200 will create 200 into 1. So it is going to be bending moment at A is 50 into 2 plus 200 into 1. The answer will be 300 kg meter. Very good, guys. Next question in front of you. बहुत ही बढ़िया, guys. So slowly we will improve the level. Slowly we will increase the level. What is the answer for question number 4? They have given you SFD and BMD and there are some options in front of you. So they have given you SFD and BMD and there are some options in front of you. बहुत ही बढ़िया, guys. Solve it. Guys, do like and share the session. Do like and share the session so that other student can also be benefited. SFD and BMD for a beam ABCD are given to you. Yes, Deepak, Vishweshwar, try this. Madhuvamshi, Midun, Vipen, Kalpesh, Manas, Kenil, Amir, Bhavya. Okay, Bhavya, today you got late. Huh? But you answered it first. Very good. So according to Bhavya, the answer is C. Shubhankar is saying C, Mani is saying D, Midun is saying C. Okay, so there is a confusion among C and D. Very good. All of you guys. Vipen is saying C. So guys, first of all, if you see this, I want to tell you something. That wherever you get the jump in the SFD, there would be some point loads. Wherever you get the jump in BMDs, you would be having some point moments. So you can see there are 3 jumps in point forces, 1 jump in point moment. So the beam has 3 support and A is fixed. So you know that if the fixed support is there, it gives a bending moment reaction. So my dear, can you see any jump at A? There is no jump at A in bending moment diagram. So that's why this is wrong. If he would be saying the beam has 3 supports up to this, then it would be correct. But my dear, when this point is added, this is wrong. So that is why A option is going to be wrong. Second is and A is fixed. Obviously this is wrong. A couple of 200 Newton meter act at C. Yes, because at C we have a jump from 100 to 3000 to 3000. So this is a jump of 2000 Newton meter. C is correct. UDL is confined to portion BC. So if you see in BC, you have horizontal line SFD. So it means there is no load during this. So if you want to say there would be point load here, point load here, point load here, and point moment here. If you want me to draw a loading diagram, then you can see here this is downward, means the load should be like this. Here this is upward, it means the load should be like this. And you can see there is a moment, yes, and that moment is of 2000 Newton meter. So here will be the point moment, okay? Let us say this. And then you know that there is a jump. There is a jump, yes. So you know to the left hand side upward, right hand side downward is positive. So it is going to be positive, okay? So right hand side downward is positive. So this is going to be the diagram if we are talking about, okay? Yes, so bending moment direction I have not checked. I have just told you the points where the loads would be acting here. So let us see question number 5, my dear. This is a good question now, okay? Slowly we are increasing the level. Bahut hi badhiya. So guys, just like and share the session. Solve this one. An overhanging beam ABC is supported at points A and B as shown in the figure. Find the maximum bending moment and the point where it occurs. You need to find out the maximum bending moment. So to find out maximum bending moment and its point, Mani, I told you that I have not checked the direction. I have just arbitrarily applied. I wanted to show you the point and the types of load. I have not taken care of sign convention. Okay, I have just given you the points where the loads will be acting. So let us talk about this. You will be finding out the support reaction at A first. Find out the support reaction at B first. Once you find out that, then my dear, you can definitely go for SFDs and BMDs, and then you can find out the maximum bending moment. Okay, so just try to solve it, guys. It is a very good question and you may get this type of question in GATE for sure. Sir, ये session रहेगा ना YT पे बाद में भी? Okay, Bhavya, yes, it will be there. So where are you busy? Yes, it would be there for sure. Solve it, guys. Solve it. So first of all, find out the support reaction at A and B. And my dear, once you will get the support reaction, you will get the SFD. And once you will get the SFD, we can see the maximum bending moment. Yes. What are you getting as RA and RB? Please tell me that values. RA and RB values. Yes. Yes, guys. What would be RA and RB values? Shubhankar is saying 2 and 10. Okay, Madhuvamshi have given the answer A, Mani have given A. Kenil, good evening, kahan reh gaye? Ramon, very good. I have taken name of yours 4 times in the session. I was thinking, where is Kenil? Yes, so 2 downward, 10 upward. Very good. So guys, you will be getting RA as equals to, I have calculated for you. RA will be coming out to be -2. RB will be coming out to be +10. Minus means assumed direction is wrong. So in reality, this is going to be 10 and this will be acting in downward direction. Okay. So that is the reality and the value of this is coming out to be 2 kilonewton. So when we are going for shear force diagram, let me tell you about the sign convention. To the left hand side upward, right hand side downward is positive. Left hand side downward, right hand side upward is negative. So if you take the section to the section right hand side downward is positive. So there will be a jump of 6 kilonewton here. C to B, there is no load, we will be coming here. Section validity over at B, we will take another section from B to D. So you can see to the right hand side upward, to the right hand side upward is downward. So there will, upward is negative. So there will be a jump of 10. So this is -4. So my dear, from this B to D, there is no other load. So diagram will be going like this. After that, you know, the section will also be having expiry. This section is valid from D to A. To the right hand side, downward is positive, so there will be upward. This is going to be -2. And now you know this would be the complete diagram. So this is negative, this is positive. Now by looking at this diagram, can you tell me where will be the maximum bending moment? Wonderful guys. So guys, do like and share the session. Where you will be having, okay, many of you have given the answer as A, that's great. Can you tell me where you will be having the maximum bending moment by looking at this? Yes? बहुत ही बढ़िया guys. We will be having maximum bending moment at this point because here shear force is going to change the sign. The point where shear force changes its sign, we get maximum bending moment. And you can see at this point, shear force is changing its sign from positive to negative, negative to positive. So at this point, we will be having maximum bending moment. You also know that we can write MC minus MB is equals to area of shear force diagram between B and C. Yes, Sachin, are you getting it or not? So you know bending moment at C is going to be 0 because it is a simply supported overhanging beam. So if you will write here minus MB, the area is going to be this one. This is 6 into 1. It is going to be 6 kilonewton meter. So we are finding out the bending moment at B. So it is coming out to be 6 kilonewton meter. So 6 kilonewton meter at right hand side support. A is the right answer. You guys have done it very nicely. Yes, Kenil, I have seen. Don't worry. I have seen that actually the session got delayed by some minutes. So sorry for that. And yes, Priyanka Tiwari, welcome to the session. So guys, are you getting it properly? We have completed 5 questions. Now we are entering to the 6th one. Wonderful guys. Wonderful guys. So this is question number 6. Try to solve it, guys. Question number 6. Try to solve it, guys. Yes, this is a relatively easy question, I feel so. A freely supported beam means simply supported beam. Okay, at its ends, it is simply supported. And they are saying that carry the central concentrated load W. And they are saying the maximum bending moment for this beam is coming out to be M. If the same load on the same beam is applied in the form of UDL, then what would be the bending moment maximum for this? Maximum bending moment is M here. What is maximum bending moment here? This type of question can come in 1 to 2 marks both. Wonderful guys. Yes, Sachin, Kenil, Manas, Ramesh Mon, Vipen, Midun have given the answer as B, बहुत बढ़िया. Kenil have given the answer as B, बहुत ही बढ़िया. Kalpesh, very good. Shubhankar, very good. Vipen, very good. Sushobhan, Priyanka, बहुत ही बढ़िया. सभी के आंसर सही except Shubhankar. Shubhankar, you need to check it once again. The answer for this will be B. Yes. I will tell you how it is. Beast incarnate, very good. Naveen, very good. Yes, Madhuvamshi, what is your answer? B. Okay. Sachin is saying B. Mani is saying B. Very good, very good. So guys, I am telling you that whenever we have this simply supported beam and load is W acting like this, you know, if we make the BMD for this case, BMD is coming like this. So my dear, you know, this value is the maximum bending moment, which is WL by 4. And on the other hand, if we have UDL on this entire beam, you know that here the bending moment diagram will be coming like this. Like this. So this will be the maximum bending moment. And we will be getting maximum bending moment to be equals to WL square upon 8. And you know that capital W is W into L. So we will be getting WL by 8. So previous one was WL by 4. If this is M, then my dear, what would be WL by 8? It is M by 2. Yes, guys. So answer is very clearly m by 2. Hope everyone got it. Very good, guys. बहुत ही शानदार. Let us move to the next question. Question number 7 in front of you. A beam supported over span length L carries two loads each at a distance of L by 3 from each end. So guys, this is VA, this is VB. You have a load here W and a load here W. L by 3, L by 3, L by 3. They are asking the slope at A and B. You can very easily find out slope at A and B if you apply which method? Moment area method. Yes, make the BMD. लगा डालो इसको भी. Yes, इसको भी ठिकाने लगा दोगे. It is a very easy question, I will say that. And this type of questions are coming in GATE examination. They are 2 marks questions started now. Okay, so we are having today also 20 question. You know, every day we are doing around 20 questions, guys. Okay, yes. Even I feel we are going to exceed the target of 500 plus. Okay, so if we go by 20 question daily, definitely we are going to exceed the target, because target was of 15 questions in 1 hour. So I am taking 20 question in 1.5 hours. So you are going to get more number of questions. Are nahi money. If you will go by Macaulay method, we will not be able to solve any other question in this session. So go by Mohr moment area method. Okay, for that you need to make the bending moment diagram. Go by Mohr moment area method. This is going to be the bending moment diagram. You know that symmetry is there. So because of symmetry, this support reaction will be coming out to be W and W. And you know that the deflection diagram is this. This is going to be the maximum deflection and zero slope. So you can say this is point C. You need to write the equation from Mohr moment area theorem number 1. You will write theta at C minus theta at A is equals to 1 upon EI into area of bending moment diagram between A and C. You just need to do that. And you know this value is W, so this value will be WL by 3. WL by 3. Arey bhai, force into perpendicular distance is moment. There is nothing lengthy calculation is required here. Yes, Mani solve it, Priyanka solve it, Shubhankar, Midun, Beast Incarnate, Sushobhan, Sachin, try to solve it, guys. Kenil is saying the answer to be B. Very good. What about others? Kalpesh is saying B. Okay, Shubhankar is saying done. Okay, very good. At least you are trying, guys. What about others? Yes. मधुवंशी बी, बहुत ही बढ़िया. मनी बी, बहुत ही बढ़िया. वंडरफुल गाइस, बहुत ही शानदार. So guys, the answer for this is yes, B. No doubt about that, the answer is going to be B. Ramesh Mon, Manas, Naveen, Shubhankar, बहुत ही शानदार. So guys, let us make the equation. You will be writing theta at C minus theta at A. You need to find out this. You know that this is the area of triangle and then this is the area of rectangle. So you need to write these two areas. Okay, so let us write first of all the area of triangle. 1 upon EI is coming outside. It is 1 by 2 WL by 3 into L by 3. Then my dear, plus the area of rectangle is, you know that this total length is L by 2. This length is L by 3. What is L by 2 minus L by 3? It is coming out to be 6. 3 minus 1 into L. It is L by 6. So you will be writing plus WL by 3 into L by 6. You will be getting, guys, theta at C is 0. You already know from the boundary condition. Theta at A will be minus WL square upon 9 EI. Similarly, when you will be finding out theta at B, it will be coming out to be plus WL square upon 9 EI. Because you know at both the supports, at one end slope is clockwise, at other end slope is anti-clockwise. So answer for this is going to be B. Wonderful, guys. Yes. No issue, Shubhankar. That's why these sessions are. We are going to help you for that. If you forget, we will give you the method again. Don't worry, guys, for that. Yes. If differentiation sum of x bar, right? Yes. AX bar. Very good, Ramesh Mon. So, guys, this is the continuous beam shown in the figure below, subjected to UDL. They are saying the value of central support reaction becomes 0 if central support sinks. Actually, they want to say that, you know, if this support would not be there, then this beam would be deflected like that. So when this support would not be there, support reaction would be 0. So they are asking you, what is this deflection actually? What is this deflection actually? For that, this support reaction is 0. That is nothing but the deflection if support is not there. Arey bhai, support is there for reaction. If no support reaction, no support. It is a simply supported beam. They are asking you the central deflection. Try to find out. The only difference is here length is L plus L to L. Try to solve it, guys. Kalpesh is saying B. Okay. Wonderful. What about others? Okay, I am going to correct it. This is WL4 upon 4.8 EI. Okay? Yes. Solve it, guys. सोच समझ कर आंसर करिएगा. I said this length is L, this length is L. Total length of the beam is 2L now. सोच समझ कर आंसर करिएगा. Okay? Think twice before answering this question. Midun is saying D now. Arey, don't say D because I have changed the option. Okay, solve it first. Kenil is saying A. Madhuvamshi D. Nagaswamy D. Priyanka is saying C. Okay, so different students, different answers. Very good. Yes, that means question is good one. So, Nagaswamy, where were you? You also got delayed. Abhishek Shivam is saying A. Shubhankar is saying B. Okay. So, guys, now let us see. If I ask you that this is a simply supported beam and this is the UDL. So, definitely from the table you must have remembered that for this case, if we see the deflection, this would be the deflection. So deflection at C will be coming out to be 5WL4 upon 384 EI. Okay, so this you must have seen in the table I have given to you. So 5WL4 upon 384 EI. But dear, here the length is not L, here the length is 2L. So if length is 2L, you need to keep 2L in place of L. It will be 5W 2L to the power 4 upon 384 EI. What do you understand by 2 ki power 4? It is 16. So you will be getting, my dear, WL4 upon, yes. Is it clear what you will be getting here? You will be getting it as 4.8 EI. Okay. Is it clear? Okay, A and D options are same, you are saying. Okay. Then okay, both are correct. Okay, then I shall not change the option actually. Okay, so it is MSQ. You can feel it like that. Fine, A and D both are correct. Okay, so I forget that A is correct. That's why I changed this option. I thought maybe otherwise you will not get the answer. Yes, it's correct. Fine. A and D both are correct. So it will be acting like MSQ for us. Okay, because chances of errors are there otherwise. Let us see the next question. Question number 9, guys. Yes. This is, guys, from principle of superposition. So guys, do like and share the session. Still we are left with 11 more questions. Okay. So this is going to be the wonderful practice session for all of you guys. The most important topic, SFD, BMD and deflection. So guys, in a cantilever beam of uniform flexural rigidity EI loaded as shown in the figure, find out deflection at B. So guys, let us say this is C and this is the fixed support. So I am giving you the hint. There are two ways to solve it. One is principle of superposition, other is area moment method. So my dear, if you will be going for the principle of superposition, then you know that it is going to be deflected like this. So this is deflection at C and this is deflection at B. So you know that this part we are writing it as theta at B into length of BC. So we can write deflection at B as deflection at C plus theta at C into BC. This is the principle of superposition. How I have written that? Because if this is theta and this is BC, so this is going to be BC into theta. Yes, it is going to be curvature, but theta is very small, so we can consider it as straight line. So my dear, this is going to be the best way to solve such type of problem. Very good. Very good. Kenil is saying D. Very good. Madhuvamshi D. Nagaswamy D. Wonderful, guys. बहुत ही बढ़िया. So just try to solve it, guys. Just try to solve it. I am helping you in that also. If we have a cantilever beam and load is acting like this, L is the length, then this point deflection at C will be PL cube upon 3 EI. This is also from the table. So guys, tomorrow I will be sharing you the table of all the formulas of centroids, moment of inertia, SFDs, slope and deflection, as Sushobhan requested that. Yes, Sushobhan, are you there or not? Shubhankar is saying D, Ramesh Mohan D, Sachin Gautam D, Vipen D, Kalpesh D, Kenil D, बहुत ही बढ़िया. And guys, the answer is also D. So you know that how you will be writing it. Deflection you need to find out at B. It is deflection at C plus theta at C into BC. You know that Y at C is PA cube upon 3 EI plus PA square upon 2 EI and it is L minus A. So you would be having 6 EI. Yes, this will be 2 PA cube plus 3 PA square L minus A. So you would be getting it to be PA square 3L minus A upon 6 EI. So answer is going to be D for this, guys. I feel everyone is getting it. Next question, guys. Sir, can you take that doubt? Yes, I am going to take that. Don't worry. Tomorrow is the column topic, na? So I will take that. Madhuvamshi, that also we are going to plan soon. Okay, that will be a separate one. I am planning it on Sundays. Before that, I will be taking a session how to choose second paper. Okay. Next question. For the beam shown below, the ratio P by Q when deflection at C is 0. Deflection at C is coming out to be 0. So this is a cantilever beam. Here the load is P. Here the load is Q. This is L. This is L. And they are saying this is C, this is B, and this is A. Deflection at C is 0. Then what is the ratio of P by Q? Solve this one, guys. This is a very good question. I will say that. Arey wah, Ambati, very good. Amati is saying the answer is D. Madhuvamshi is saying D. Nagaswamy Iyer is saying D. Arey, you guys are really champs. Very good, guys. Wonderful. So do like and share the session, guys. Still we are left with 10 more questions. Kenil said D. Shubham said D. Shubhankar D. Sachin D. Bahut hi badhiya. Ramesh Mon D. Very good, guys. Very, very good. So guys, if you see this, we can also go by moment area, or we can also go by which method? Yes, we can also try principle of superposition. So my dear, you know that initially let us consider there is a load P acting. So because of this P, you know this is going to be the deflection. This deflection is P 2L cube upon 3 EI. That is downward deflection. Then my dear, you can consider another load Q. It will be definitely doing the deflection like this. So you know this is upward deflection. What is this? This deflection is nothing but deflection at C due to Q. It will be, this point is B. You know that this is going to be deflection at B plus theta at B into BC. Okay, then deflection at B, you need to find out this is the length L. So you will be writing deflection at C is equals to, this is because of Q. So Q L cube upon 3 EI plus Q L square upon 2 EI into L. But this is upward. So my dear, this is YC because of Q. This is YC because of P. You need to equate them equals to 0. Or you can just equate them. Okay. So you can write deflection at C because of P plus deflection at C because of Q is going to be 0. One is downward, other is upward. Okay. So downward will be shown by negative. So minus P 2L cube upon 3 EI plus Q. This you can see QL cube upon 3 EI plus QL cube upon 2 EI. Put it 0, you will get the ratio as 5/16. And the answer for this is D. Okay, anything you are saying? Sir, where we will get formula, PDF, deflection rule? And so dear, okay, sorry. So you will get that on my Telegram channel, Mechanical by Dheeraj Sardana. So guys, I am just sharing the Telegram channel link because many students were asking about that. So I am sharing that, guys. Don't worry. Okay. So just join that Telegram channel so that you guys can get the benefit of all the study material I am sharing. I am also sharing daily practice papers there. So guys, just take the benefit of that. Okay. So I am just sharing the link. Yes. Okay. Wonderful, guys. Sir, superposition is best in cantilever, moment area is best in simply. Yes, dear, that also you can say, but it depends how you approach the problem. Let us move to the next question, guys. Every student have their own best. This is the question of the day, guys. I will say this is the best question for today. Okay. So many students just by looking at it would be feeling bad. But here for this question, you need not to go for much calculations. Just some better understanding of concept is required. And for that purpose, I have taken this, and I am feeling that such type of question will be surely coming for 2 marks in GATE examination. So this is the benefit of your live workbook. Yes, try to solve it, guys. The first thing you shall do is to find out the support reaction at A and B. After that, no need to do for anything, no need to go for anything. Just by looking at the way bending moments are coming, you will be able to solve it. Aspirant is saying A, Madhuvamshi is saying B, Kalpesh is saying B, okay, Shubhankar is saying B. So guys, I have shared the Telegram channel link. I feel you got it or not? Yes. So the name of channel is Mechanical by Dheeraj Sardana. If possible, any student who are already there in Telegram channel, do share the link in the comment section. Okay. Otherwise, I will be sharing at the end of class. Sushoban is saying B. Okay. Kenil is saying B. Sachin is saying B. बहुत बढ़िया. So guys, the answer for this question, tell me guys, still I am waiting for many others. What would be the right one? A or B? Still 9 questions are left. A or B? Very good. Okay guys. Yes, Kalpesh have shared the name of the channel Mechanical by Dheeraj Sardana. If anyone is not joined that, do join it. You will get a lot of benefit. So guys, if you really want to understand this type of question, just follow the step and just help me to solve it. Because many of you have tried. Yes, definitely your try was good, but you have made some mistakes. So just to rectify that, let us solve in my way. First of all, tell me the support reactions. You can see this is overhanging beam. Shortcuts are not applicable. You will write this is VA, this is VB. So you can write VA plus VB is equals to the total load. This is 0.5L into W. W into 0.5L. This is 2W into 0.25. 2W into 0.25L. So what we are getting VA plus VB guys? Are we getting it as W into L? Am I correct? Please tell me that. Okay, no issue Vipain. You just WhatsApp me on this. I will add you into the group. I will add you into the group. Okay. So shall we move on guys? Very good. Very good. So guys, let us see now. Take the moment at A to be 0. Summation moment at A to be 0. You can see my dear, this entire UDL will be acting at its centroid. W into 0.5L will be acting at a distance of 0.25L. We can take it in this way. And this UDL of 2W into 0.25L will be acting at a distance of 0.125L. So when you will be taking summation moment at A0, this is creating clockwise. So I will write plus W into 0.5L. And the distance is 0.5 plus 0.25, 0.75L. Then this VB into 0.5L. And then you know for this load, 2W into 0.25 is going to be 0.5 WL. So it is going to create once again clockwise, 0.5 WL. Distance is 0.125L. When you will be equating it to 0, you will be getting the value of VB. I am telling you, you will be getting what VB and VA values as. Yes. Sure. I will share that also in the Telegram channel. So you will get RB as 0.875 WL. And VA you will be getting as 0.125L. I already told you, if you are talking about SFD-BMD, if you are going to use shortcut method, support reaction calculation is a must step. Why I told you that? I am telling you. Because by knowing these reactions, you get to know whatever the direction we have assumed, they are correct. So once we get that, now we need not to do any calculation. You can see, you already know we are going for BMD. So you can see this loading diagram. You know this is going to be the sagging and this is going to be the hogging. So if I take any section here, to the right hand side, this loading is doing hogging. So from the right hand side, bending moment should be negative. Bending moment is negative here. Bending moment is negative here, negative here, negative here. So any of the 4 can be correct. But here as this reaction is going to be positive, it means direction is correct. If you take any section here, this will be creating sagging. This is distributed load. It will be starting from here. It will nullify the effect of positive, but initially it should be positive only. So you can see from left hand side, it is positive either here or here. So my dear, either A will be right or D will be right. That is for sure. But if by chance you would be getting negative reaction, then my dear, you cannot say A and D is correct. Now you can see at D there is a jump, but there is no bending moment, which is point moment is acting. So D cannot be our answer. A is the right one. Understood or not? Are you got something new or not? Yes, slight calculations are there, but this is the beauty of SOM. A would be the right answer, guys. Hope you are getting it. Moving to the next question. Question number 12, guys, in front of you. Yes, so guys, I already told you we will be having easy to moderate to difficult. Okay, because every student is in different phase of preparation journey. Some have just started, some have done it and they are doing the PYQs. Some have done PYQs, they are just attempting the test series. Some have given the GATE exam, they are retrying. So I need to take care of all. Okay, yes. So a cantilever beam of length 4 meter carries a UDL of intensity W throughout the length. Okay. If the maximum bending moment in the cantilever beam is 100 kilonewton meter, EI is the flexural rigidity, slope of the free end for the cantilever beam. Very easy question. So as I told you, some questions are easy, some are difficult. Nagaswamy, are you there or not? Yes. What would be the answer? Great. So solve it, dear. I'm waiting for your answers. And guys, do like and share the session. अभी भी 8 क्वेश्चन बचे हैं. अभी भी 8 क्वेश्चन बचे हैं. 8 questions are still there. So today we will complete, I feel, up to 10 PM for sure, because 8 more questions are there after this. But don't worry, some easy question once again will be coming to motivate you also. Okay. So I need to show you the level as well, and also I need to motivate you. So both type of questions are there. Kalpesh is saying B, Kenil is saying B, Ambati B, Shubhankar B, Madhuvamshi B. Yes, very good, guys. You guys are going nicely. Sushobhan, very good. So guys, yes, the answer for this question is B, no doubt about that. So guys, if you see this, you know that the maximum bending moment at the support is minus WL square. Minus WL square by 2. This is the maximum bending moment. And they have said that this maximum bending moment is 100 kilonewton meter. This is 100. And you know slope. What will be slope at A? We have derived the equations. It is minus WL cube upon, what would be the slope? Yes, 6CI, and deflection would be ATI. So you know that WL square by 2 minus WL square by 2 into, this is L by 3 EI. So you will be getting the answer to be 400 by 3 EI. How clean this question is. Okay, how clean this question is. The answer for this is going to be B. Let us move to the next question, guys. Once again, easy one. So we have all the types, guys, for all the types of students. Wonderful, guys. Do like and share the session, guys. अभी भी 7 question बचे हैं इसके बाद. This is simply supported beam. Simply supported beam. And there are 3 point moments are acting. You need to see which of the diagram is the correct bending moment diagram for this. Wonderful, guys. बहुत ही शानदार. Madhuvamshi is saying B. Okay. Kenil is saying A. Kalpesh is saying A. Okay. This is question number 13, I feel so. Okay. Kenil is saying B, Aspirant is saying C. Okay. So guys, let us see this question. First of all, as there are 3 point moments, there should be 3 jumps. But the problem is, here is 1 jump, here is 2 jump, here is 3 jump. 1 jump, 2 jump, 3 jump. 1 jump, 2 jump, 3 jump. There is no jump. So this is wrong. Still we have 3 options A, B and C. So we need to see which one is going to be correct, my dear. And if you see, if we make this section to the right hand side, it is anti-clockwise. This is sagging moment. So the jump should be positive. So many students would be thinking that, sir, jump is positive. It should go in upward direction. But my dear, do you know that examiner, why he is there? Why he is examiner? Why we are student? The reason is he know how you can make mistake. He have mentioned minus sign here. Means he is making upward negative, downward positive. You can see this. And none of you would have seen this. So guys, the answer is going to be in such a way that negative is positive, sorry, downward is positive. So my dear, if you see, this M jump should be downward. So you can see M jump is upward here, upward here. Upward means negative here. Both are wrong. This is correct. Are you getting it, guys? This examiner, I feel it is asking like I want to ask the question. This is how, just by giving a small twist, all of you are in danger. Question number 14, guys. After this, we are left with 6 more questions. 5 to 6 more questions. Great, Kalpesh, great. Yes, Manas. So enjoying the session or not? Yes, Nagaraju, are you there or not? This is the beauty of SOM, guys. अरे यार अंबाती ऐसा नहीं है. Every human can make the mistake. So a beam ABCD with simple supports at A, B and D, an internal hinge at C is subjected to the loads. The reaction at middle support B is given by. You need to find out the reaction at B. Yes, guys. So try to solve this. It is a case of compound beam. And my dear, I will tell you about one thing, that C is internal hinge. And you can take the help of it. How you can take the help of it? Bending moment at C will be 0. Use this. Try to find out the things. Yes, solve it, guys. Great, great, Krishan. Ramesh Mon is saying the answer is D. Okay. What about others? Ambati, Kalpesh, Ramesh Mon, Madhuvamshi, Sachin, Manas, Sushobhan, Priyanka, Nagaswami Iyer. Ambati is saying D. Okay. Very good, Ambati. Mani is saying D. बहुत बढ़िया. Kenil is saying D. Mani is saying D. बहुत ही बढ़िया, guys. Wonderful. Sachin Gautam is saying D. Sushobhan D. Abhishek Shivam D. Guys, the answer is D. No doubt about that. So you know that there is a support reaction RA. There is a support reaction RB. There is a support reaction RD. So you know that first of all we can make it as 2 beams. RA 20 RB. And at C there is a hinge. This is RD. You know this load is 20 kilonewton. So you know that as per the rule we will assume a support reaction here, that is RC, and the same will be coming here RC. By symmetry this is 10, this is also 10. So this is also 10. Now this is overhanging, no shortcut is applicable. We will be going for summation moment. at A to be 0. So my dear, you know the length as this is 1, 2, 2, 5. So you can write RC into 5 plus RB into 4. This is RC into 5 minus RB into 4. Then you will be having 20 into 2. Putting it 0, you will be getting RB as equals to 22.5. D is the right answer, guys. No, aspirant. Actually, we are going for all the subject. This is GATE Champion series, where we are covering some 500 plus question and total from all the subjects. SOM will be there. Last class of SOM is tomorrow. 3 classes are completed of SOM. Today is the 3rd class. Tomorrow is the last 4th class. After that, different subjects will come. Engineering mechanics is scheduled on the next Sunday. Okay. हाँ, permitted elongation नहीं है मधुवंशी. Yes, next question is this. SFD of the loaded beam is shown in the figure. Corresponding loading diagram is. This is the new type of question because I already told you till date they are giving loading and asking SFBM. Priyanka is saying A. Madhuvamshi is saying A. Wait, Kenil, we are having a question that is related to the 2 connected cantilevers. Yes. Kenil is saying A. Okay, Madhuvamshi A, Priyanka A. Kalpesh is saying A, bahut badhiya. So the answer for this question, guys, if we see, you can see there is one jump here. Let me show with the other color. One jump here, other jump here. So there are 2 jumps. Okay. So my dear, there is 3 jumps are there. So if you see here also 3 loads, here also 3 load, here also 3 load. Then my dear, you know one thing that whenever we are talking about this kind of thing, we need to go with sign convention. So let us take a section. Let me take the section here. And you know the sign convention. To the left hand side upward, right hand side downward is positive. This is going to be negative. So my dear, to the right hand side downward is positive. Here is positive. So this can be the answer. This cannot be the answer. This can be the answer. This can be the answer. So first of all, B is eliminated. Then my dear, you can see the section will expire at this point. We will take the next session here. From this to the right hand side upward is negative. So jump should be downward. Yes, this is downward here. So this can be the answer. This also can be the answer. This also can be the answer. Then my dear, after that, if you see this to the left hand side downward, to the left hand side downward is negative. So my dear, this can be the answer. This cannot be the answer. This cannot be the answer. Okay. So either A or D can be the answer. Either A or D can be the answer. Then my dear, you can see this is for 2 meter. This is going from 47 to some value. So this is 47. This is 47. Here also all the time 47. Here UDL is downward. So here UDL is upward. This is also wrong. So we are having left with A only. A is the correct answer. I feel everyone got it. Very good, Viresh. Moving to next question. Question number 16. This is the easiest question of the session. My dear, it is the easiest question of the session. So I told you we have kept all basic, medium, average, good, tricky, lengthy, everything is there. You know dm by dx is the shear force at a distance of x is equals to 2 meter. Try to solve it, guys. Very good. Just after looking, many students have answered it. Kenil D, Aspirant D, Madhuvamshi, Midun, Kalpesh. This type of question everybody wants to be there in paper. That is why cutoffs are going higher then. The answer is going to be D. Okay. So guys, it is going to be 10x plus 20. Answer will be 40. Wonderful, guys. Moving to question number 17. Yes. Very good. Don't worry. those strain energy method questions are also not difficult here. This is also a very good question. You know that this is an internal roller mentioned. So when we have internal roller, this is another one. Okay. So when we have internal roller, we need to consider it in upward direction here, downward direction here. This is, let us say, RB. So my dear, now you know that deflection at B is going to be equal. Find out deflection at B from this beam. Find out deflection at B from this beam. Equate them. You will get the value of RB. This is the question, guys. So you know that if you will be finding out deflection, this UDL will be doing in the downward direction, RB will be doing in upward direction. So you will write minus W into 4A to the power 4 upon 8 EI. Then plus RB L cube upon 3 EI. Then it is equals to plus, okay, this time it is going for down only. So I will be putting negative sign. So negative sign will be there. You will write minus W into 2A की power 4 upon 8EI minus RB, this L is also 4A and this L is 2A, L cube upon 3EI. You will get the value of RB. Very good. So Gajodhar, where were you भाई? शुरू से नहीं आया आज. Sachin is saying D. Priyanka is saying D. बहुत बढ़िया. Gajodhar is saying A. Okay. Tell me the answer, guys. A, B, C, D, what? Actually, they are asking you the deflection at B. So once you will get RB value, then you can find out deflection at B also. It is minus W 4A 4 by 8 EI plus RB L cube upon 3 EI. Solve it, guys. So Utkarsh have given the answer to be A. Utkarsh have said A. Rest are saying D. Yes, can you tell me what you are getting as RA? I will say Utkarsh, answer is correct. A is correct. What you are getting as RA, can you tell me that? What are you getting as RA? Can you tell me that? Are you getting RA as 5WA by 4? So if you are getting 5WA by 4, putting this value here, sorry, not RA, RB actually. So if you are getting this, putting the value in the equation, you will get A as the right answer. Very good, Kalpesh. Is it clear for everyone? Please tell me, guys, two more questions. Two more questions now from one part of the beam is rigid. Two more questions, then we are completing the session in next 5 to 7 minutes. Question number 18. You need to answer about the maximum slope. So this is the case. This part is rigid. So in this case, you know that this is C, this is B, this is A. Slope at B will be equals to slope at C. But what will be that? You need to find out that. Maximum slope is. Try to solve it, guys. This is the second last question for today. And guys, you will be getting the DPP3 tomorrow morning and solution of DPP2 tonight. Okay. So daily practice paper 3rd will be coming in tomorrow morning. So you know, morning we are having the DPP, evening we are having the solutions. Madhuvamshi is saying B. Mani is saying B. Gajodhar is saying B. Very good. So everyone is giving the answer. You know that this bending moment M and this bending moment M. M plus M will be 2M. So my dear, you can feel it that this is the beam on which 2M of bending moment is acting. So you know L is the length. So the maximum slope will be 2M L upon EI. Answer is B. All of you are correct, guys. I feel Ramesh Mohan have given the wrong answer. Yes. Is it fine, Ramesh Mohan? You got it? M plus M, you forget about that. What if it is rigid? The effect of bending moment will always, definitely it cannot deflect. But load is acting, na? Okay, Mohsin Ali. Yes, thanks, dear. I also feel very happy when some previous students are coming to see. So thanks, dear, for watching the session. And I feel you are fine. Gajodhar, very good. So dear, when we are talking about this C to B, this is rigid beam. It will not be having any deflection. But if you will find out bending moment at any section, that is independent of whether the beam is rigid or not. Bending moment will be counted normally only. If you will be finding out deflection, then my dear, you will be using the same principle of superposition. Deflection at C will be deflection at B plus theta at B into BC. Is it clear, Utkarsh Urf Gajodhar? Deflection at C is deflection at B plus theta at B into BC. Because this part, rigid part, that can not deflect like that. But that can rotate like that. Is it clear for everyone? Next question, guys. The last question for today is maximum deflection. So you need to find out deflection at C now. It is deflection at B plus theta at B into BC. Why we are doing it? Because this rigid part can rotate like this, but cannot deflect. Okay? This rotation is possible, but deflection is not possible. So that is what I want to say. So in this case, you will be having deflection like this. Like this. After that, it will remain like this. So this will be deflection of B. Deflection of B. Theta B into BC. Yes. Parth Kumar is saying B, Ramesh Mohan is saying A, Gajodhar is saying A. Okay, let us see. The last question it is. So guys, A or B, tell me that. You know that when we are talking about theta B, you need to find out Y at C, Y at B, plus theta at B into BC. You know that theta at B was 2M L upon EI. Similarly, Y at B will be 2M L square upon 2EI into L. The answer is very easy to find out. 3ml square upon 2EI. So guys, with this we have completed the question. The answer is A for this. Very good, Sushobhan, Sachin. So guys, a lot of thanks to you guys for your love and support to this GATE Champion series. So guys, before leaving the session, do like and share the session. Okay. Yes, Kenil, definitely EI will be coming. I forget to write. I have written, na? EI will be coming for sure. Okay. So my dear, we have completed these questions. Okay, 3 by 2 nahi aayega. Very good. So you are saying only this will come. Fine, fine, fine. Great. Okay, so finally the session is about to complete, guys. So just like and share the session after completion also before leaving. Tomorrow's sessions are going to have the topics of columns, thermal stresses, strain energy impact loading, testing of properties. Okay. So all these topics would be there, and I will add the strain energy topic, like Kenil was asking about the question of strain energy method. I will add one question of that. Okay, and guys, those who have not joined the Telegram channel, do join it, because you are going to get daily practice papers. And from next, you can say after 1-2 days, we are also going to start the DPP schedule, and the complete revision plan I will be sharing with you. So you will be getting benefit of that. Bhuvi ka match kaisa raha? Match to badhiya hi tha dear. Okay, so yesterday, as all of us were watching the match, so that's why class was rescheduled. Okay guys, so goodbye for this session. Thanks for joining. We will meet again tomorrow at same time, 8:30 p.m. Goodbye.